Welcome all. Hope you all are doing well. This is Brandon Young, lead up ecosystem stuff for Tabnine. We may give a few minutes here. We're going to do some basic intros as everyone's joining. We appreciate you all spending some time with us. So I'm going to give you a little content, or I'm going to do quick intros and then a little context, and we'll get started. So again, Brandon Young, I lead up ecosystem, which means I try and figure out all the wonderful ways Tabnine can work with the rest of the world. I hand it over to Adrian for a quick intro, and then over to our guest, Matthias.
All right. Hello, everyone. Welcome back. I'm Adrian Howard. I'm the Principal Product Evangelist here at Tabnine, located in Manhattan.
And hello, everybody. My name is Matthias. I'm super honored of being able to share this time with you. I'm with Cohere, and I am calling from France.
And I'm going to have already messed something up with the name right off the bat. So, Matthias, I'm sorry. I don't know why. Too many Matthews in my life, and I started right out of the gate. So good news is only place we have is to go up from here. So with that, I think we are about 2-3 minutes in. I think we're going to just get basic start out, give you a little context of kind of where we're headed. So Adrian, if you don't mind, I think up and there we go. We're up and running. So a little bit today, let me a little context setting for those of you coming from probably one of two worlds. So just kind of know what we're going to be going through. Tabnine is the application that is the front end to generative AI for your code throughout your software development lifecycle. We're going to see some demos. We can obviously get more depth and a ton of stuff out there, largely by Adrian, out on YouTube and otherwise for everyone to see. So there's plenty there, but understand that's really Tabnine is kind of the application, the interface layer that you might be using to interact with generative AI in your code space. And today we've got Cohere joining us with their Command R+ model to talk through how that's powered. So we think about these as large models, the LLMs, the generative AI models that power this technology. And Matthias is going to give us a good sense of how those are structured, why they work the way they do. We'll do some front demos. Today's a chance to go a bit deeper in that. That said, as always, questions, comments, and ideas, things you'd like to know more about, please add them in the comments. We'll be watching those carefully. We'll be trying to answer them as we go and keep the ball moving. But to that end, I'm going to do quick basics. Tabnine, we've been around about 8 years. We are the founders and originators of all the generative AI for code fun. Back when we used to say we use generative AI, everyone would look at us. Actually, the word didn't exist. We said we do LLMs for productivity. And everyone's like, okay. I was like, it's autocomplete on steroids, to which they'd be like, oh yeah, that thing, yeah, we'd like that. So anyway, obviously world's come a ways. What we want to do, again, like I said, we meet customers wherever they come from, help them run, whether that's in Get Started, and it's one of our million-plus developers, and we thank you all for being great customers and users, or our enterprise customers that like to put it behind a firewall where we get to sneakernet in Tabnine into their environment. We meet you exactly where you are with whatever kind of foundations you need, and that's a lot of what we're going to kind of cover through today. A little bit on Cohere, and I'll let Matthias jump in is here, but I know the team personally, the founder we used to work at Google together, and the team over at Cohere built a great foundational group, is now scaled dramatically with investors and partners and stuff just about everywhere. You're going to get a ton more depth on that, but suffice it to say, they are among the elite companies in the space around building complex, awesome LLMs. Today, just to be clear, we're going to be talking about a use case. That use case is generative AI for code in your development environment. That said, I think everyone's very aware this can be used in many, many, many other places for many, many other use cases. And those are ones that we can cover a little bit. I think Matthias will cover a little bit. But again, we're going to be super narrow focused a little bit today on the use case from that standpoint. A little bit of...
Can I... Sorry,
no, you can't. I'll go back.
I cannot. Totally forbid. I can just throw in an anecdote. No, you made me think
great.
when you said that when you started, how it was not always easy to explain to people what this was about. Today is an important day for me because it's been 2 years today that I joined Cohere.
Congratulations.
I remember the first time. I remember the first week I went for the hike with a friend. I'm living in a place in France, close to the mountain. And so this friend asked me, okay, what do you do now? What is this new startup you joined? And I tried to explain to him. I was really, really convinced that LLMs are cool. And it wasn't so easy. Like, it took us a few kilometers of walking to try to. And we had the same situation when I joined with clients. And yeah, I can't really believe that how much this changed in 2 years, where now people call us and ask us if they have a cool idea if we couldn't do this for them. Yep. So yeah, I just remembered what you mentioned, how things changed the last 2 years only.
Yeah, we all have short memory spans, and jump into it. To that end, because we've I think between the group here has obviously seen this through quite a few changes, but briefly, just for context sake, clearly we're looking for one area, but I think some of the things that are super important to wrap our heads around is a couple different use cases. So there's general, very, very broad use cases, of which Cohere is very strong at. But I think one area that both Tabnine and Cohere are very focused on are around those enterprise use cases. And those are going to require a different design, different handling of data, different embeddings, different RAGs, all sorts of different ways of thinking about this, because privacy, consistency, specialization, all the above are super critical for these to get adopted by enterprises. And so we will refer to that. We'll try and be super specific on what those are. Often that has to do with how the data is handled, what data goes into it, where they're run, all the above, and we'll hit those in some detail as we go. These are pretty much those foundational pieces. And again, these are coupled together. The reason we're having these conversations is because Cohere's view on this aligns very closely to Tabnine's view, and both the expectations of how data gets handled, where you can run it, and how you can manage it. So to that today, a little bit ground rules, what we're covering Cohere, particularly focus on the Command R+ model, which is pretty recently released. That said, I'm sure Cohere's on like Command Z+. I'm kidding. How you guys do naming? We'll see. I like the Command R piece, but this will be moving very quickly. So again, point in time, what you want to understand, and our goal today is Matthias is going to give us a good idea of how to be thinking about this and how they're going forward with it. These are processes you're going to need to understand more and more depth. So hopefully good education for you. We'll do some demos kind of throughout and just show that at work. And then lastly, again, please add comments, questions as we go. So I think to that, I'm going to switch it over to Matthias to talk
Thanks,
through
Brandon.
his part.
So I'm in the part of Cohere where we develop the models, and so I lead this one initiative in particular, which try to ensure that our models are good at understanding and at generating code. And so, as Brandon said, what I wanted to share today is a bit about the secret sauce inside. I won't reveal tons of details. Some of the things are generic, some are more detailed. But I thought that the audience could be interested in these types of things, so knowing how the models are trained specifically to be good at code. And so, as Brandon said, if there's any question, I do interrupt. If I don't see it, Adrian or Brandon, you can interrupt me. Please tell me, oh, there's this question here.
Yeah,
But
we already got some questions rolling in. It's around the privacy and protection of the models. If there's a better time to answer that with the slides, we can bring that in. But
excellent.
Yeah,
question.
thank you everyone for answering your questions. We will get around to them all.
I will talk about those things specifically when I talk about what type of data we use to train. And I know that this is a big concern, and it's something which we try to take very, very seriously. And so in particular, I wanted to talk about how this is trained, what type of data, and how do we use this data, and what data do we not use, and also how do we benchmark those models? How can we what are the evaluations that we use in order to decide that the newer model might be better than the previous one? And so while the order is training and then evaluation, I'm going to reverse this. I'm going to talk first about evaluation. And that's the way that we structure most of our work internally. Every time we try to tackle a new capability, we start with an evaluation set, and then we have a dashboard, and then we start hill climbing on top of this evaluation. So these LLMs, very big beasts, and then you can throw many things at them, and it's very hard to know sometimes when one is better than the other. That's why everybody does wipe checks on those things, because we try to be scientific in what we do. We have our internal benchmarks. And so the most standard ones are those you might have heard about, human eval, or MBPP, which stands for most basic Python problems. And those evaluation sets, the way that they are done is that they're assuming that your prompt, what you put inside the model, is a natural language query, and it's a description of a problem. And the output, what you're expecting, is actual code that you can copy, paste, and run. So I'm putting an example here of a very simple query that comes from the human eval data set. And then what you would expect is an implementation of this function, which is called unique digits, and which does this on, in this case, this is on Python. I think, here we go.
Adrian, now switch to him. I think I'm presenting, so he's going to go. There we go.
Here we go.
Now you're set. Good.
I'm in control now. Cool.
Yeah, I know.
Now these two data sets here, evaluation data sets, they are 5-6 years old now, and so they are so popular that they are what's called leaked. And so the way that we know that they are leaked is a number of different ways. What you see on the bottom right is actually a paper which we published recently, where we analyze a few hypotheses on why it's leaked, and we try to evaluate each one of those hypotheses. But this one is not my favorite one. So what we did here is that on the left column, you can see some of the original human eval prompts, right? So you have the first one. Let's just look at the first one. It's a function which asks for a function which would test if a string s is happy. And it gives you a definition of what happiness means. It means whatever. It has these types of characters here. And so what we did is we took a prefix of this prompt and we submitted it to an outside commercial models. And because the definition of is happy is very intrinsic to this prompt here, it's not a standard definition that you can find in programming books. What we saw is that when we get the completion, we get the correct completion. No, like it knew already what is happy was about. So this is one possible indication that the model actually saw the evaluation set, which in true machine learning strategy, normally you should have totally held out, it's very probable that it actually saw it during the training. And so we have a bunch of those where we took prompts which could be ambiguous. We took a prefix of them, then we realized that the model actually knew exactly what this was about. Now, this doesn't mean that this one commercial company did this on purpose. They might just have taken all of the data that can get their hands on and trained on it. And in particular, if you train your model on GitHub, like most of us do, you can't really avoid it, because what you can see here is a histogram of the number of times we see each one of the prompts when we search for this in GitHub. And you can see that the median here is 100, but it's 99, which means that, and the minimum number is, I think, 43. So the from the 164 prompts, which are in human evil, the minimum one which appears in all of GitHub is 43 times. So it is very hard these days having evaluation sets which are released and which you can really know that in a few months or in a few years they're going to be totally holed out. And the community knows this. They're trying different things. What we did in this one paper I shared, we released a new data set which we called LBPP, so less basic Python programs. And we know it's going to get leaked anyway in a few months. But our hypothesis is that this is an exercise where continuously you need to create new evaluation sets so that people can continue benchmarking what they're doing. There are other.
Yeah, keep going, because I think
Brian.
there's some other data, some thoughts we have on this space too, other ways of thinking of it. These are super valuable. So sorry, keep going, Matthias.
There are other benchmarks which exist. So one is called Live Code Bench. What this one does, it's a very funny way of thinking about this one. It queries periodically lead code, which is this website for competitive programming. And so it takes the newest one, and so it tests all models on the newest lead code problem which were submitted, assuming that those are totally new. Another one which has become quite popular in the last few months is called SWE Bench, Software Engineering Bench, which is a bit closer, like most of you might be using these models, although not exactly. What it does, it's assuming it has a code repository. It's assuming it has an issue, a description of a problem, and the output, what's expecting from the model, is the patch of your code base which would fix this specific issue. And this is obviously like what many of us try to do in a human-in-the-loop way when we work with the models. This one assumes that you can totally automate it. Now, none of them might really be exactly your use case. And Brandon mentioned this. I think one of the things that we love from working with Tabnine is that we are very well aligned on our values, what we want to bring to the economy and to the users. And then one of those things is that we really want to solve problems which real people have. And so we care a lot about what the customers really do. And so based on this, I just wanted to mention two different use cases which we got informed that some of the companies have, and that it's not really solved with existing current models, because maybe they're a bit less sexy or they're considered too detailed, and so they're not necessarily tackled on upfront. So the first one is a very stupid one. It's SQL. It's something which many people might not want to tackle because they consider it boring. And SQL, especially the SQL dialect, is a fascinating subtopic to work on. And so this is an example query of a standard benchmark. I think this comes from a benchmark called Spider. And so some of the existing models, the way that they answer to this is with this first one, which is called the wrong refusal, which comes because it was trained. Every time it was trained, it saw in the existing training set something which is called a foreign key in your SQL schema, which is basically something which indicates for each table how does it link to the outside table. And so because this specific example doesn't have this foreign key, the model basically says, okay, I don't know what you're asking for. I can't do anything with you because I don't have this key. What you can see below is the solution of Command R+, which we train it in a more robust way. So we give it many different ways of representing the schema. And this one is, I hope so. I didn't really check it, but I hope so. It's a correct SQL query which corresponds to a natural language query. Another real use case which people come to us very frequently And again, many people might not want to consider it because they do not consider it so passionate, is COBOL. The COBOL is this language which has been super popular in finance domain 50, 60 years ago, maybe. And there are lots of legacy software which runs on COBOL, and very few
Fun fact, 5 years ago, the language that had the most lines of code written 5 years ago was still COBOL.
Really?
Mm-hmm.
It is super solid. It is super solid because once you run it, you're totally sure it runs it. But most models are very, very bad in generating COBOL. So one very stupid thing is that COBOL depends, has a very strict restrictions on what's called divisions, those are the ways that you put your code, and each one of the division needs to start at column number 8. And so I think the first 7 ones need to be white space, and the 8th column will indicate you what column, division, what part of the code it corresponds to. And so if in your code you just strip away all the white spaces, which is a standard way that you might be pre-processing your training data, if you train it like this, then whatever you will generate is not going to be valid COBOL. It's a very just a detail. And so we created an internal test set, which is like the human eval you saw before, but specifically for COBOL, it's not for Python. The state-of-the-art model, the best one currently available, obtained 13% of pass rate on this data set. We took an internal baseline, which has 7 billion parameters, obtained 0%. We're not very proud of it. What we did is that we have a new generation of model, which was where we made sure that it saw COBOL data during its pre-training. And we know that a lot of the COBOL data is actually copyrighted, and I'm going to talk later how we make sure to remove the copyrighted data. And then what we did on top of this, we actually hired a few COBOL engineers, and we annotated some data sets, some data points. There were not a huge amount of them, but only a few. And they helped this small S7 billion model already to get very, very close to the state of the art. So what we did here is that we trained several of those. So this is why you see a variance here. So the mean is 10, and then there's a variance of 2-3 points or something like that. And those are still super low numbers, but you can see how with very little data, you can already perform quite well in what we call a low resource language. And it's a terminology which is used in natural languages, and there are some programming languages which we consider low resource. And even with a small amount of data, if you really care about them, you can actually improve quite a bit the performance. The hand-wavy explanation behind this is that the model is quite good in general programming concepts, and then what it needs to do is to understand the specific syntax of a new language and maybe some of the quirks and particularities of each one of those languages. So I'm not, I have worked with large language models for many, many years. I haven't worked with code a lot. And one of the things that I love of code are those 4 points here that you can see. So I like it because it's actually useful. I use it every day, and I can really see how it's a productivity gain. And I can see how improving our underlying, making sure that our models are good at code helps it at other tasks. As a developer, it's fascinating to do something and that you're eating your own cookie, you're using your own creation. And then finally, it is a scenario where we have a very objective evaluation, because it's not like, oh, the summary so looks better than this other one. You can actually execute the code and see how it performs on this one. And so I just wanted to talk about the second point here very, very quickly, because this is a very recent paper which came out a month ago from my colleagues, where we show that when you pre-train your data, your model with code, it becomes better at other natural language tasks. So I'm going to be very brief here in the interest of time, but I just look at the leftmost graph here. We trained 3 different models, one which has a mix of natural language and code. It's a balanced one. We trained 2 other models, one where we give it first this balanced mix, and then we continue fine-tuning on text only. Another one where we start with code only text, and then we continue fine-tuning with only text, so non-code tokens. And then I think the interesting part here is that the blue column on your leftmost graph obtains the best performance, again, the intuitive explanation here is that you try to engrave code behavior into your model, and then when it's good at code, even if it then becomes better at other tasks, it's the fact that it's good at code actually helps it to do other type of reasoning or generative text tasks. And this is why we strongly believe in having a generic model where it does code, but also does a lot of other things. So our models are multilingual, so you can ask it questions in a number of different languages, and it will answer you. And you can ask it more complex instructions on top of code, and it will answer you in a mix of those things. Let me tell you how we got here. How do we train those models? And I hope those will address some of the questions that people have around privacy. I'm not able to read all of them, but I think there are many questions around this part here. I think most of you know that the way that these models are trained is by getting lots of text data, code data. And then what you do is that you give it a prefix. So the prefix here, assume it's the green one here, give your technology, and you hide the word which comes next. And then when you train your model, you are interrogating, you query your model, asking it, what do you think is the word which should come next? And then the model gives you probability distribution over all possible words. And then what you do is you reveal what is the correct word. In this case, it's language. This might not be something that your model was expecting, which in technical terms means that your entropy was very high for this specific word. And so if that's the case, you penalize the model in order to steer it towards a direction so that hopefully next time it will give a higher probability to the word language. If it was correct, then you correct the model much less. This is what's called a self-supervised loss, because we don't need humans to actually go and annotate all this data. We just go and scrape lots of data and then we train on top of it. Because the amount of data is a limit on how good the model becomes, all these companies, Cohere including, we are super data hungry. So the more data we can get, we know the better our model is. So we go and we scrape Wikipedia, and we're happy with it. And we start scraping more and more. But in some moment, we start hitting data which we shouldn't be using because it's actually copyrighted. And today, there was yet another article of some of problems that some websites have with some of the robots, scraping robots of our competitors, because they go and they scrape all this data, even if the robots.txt doesn't allow them. And so we try to be super careful about this, again, because it's one of our guiding principles. We really want to care about the final user. So what we do, specifically for GitHub, which is the biggest repository of code data, is that when we get this data, we look for each one of the repository. What is the license under which it was released? And we remove all the repositories where the license has some type of copyright and does not allow us to train on it. Be it copyleft, be it any type of other license. We have a list of licenses which were approved by our lawyers, and those are the ones we use. Now, as a modeling expert, I would love to have all the other ones because it would improve the underlying models. But because, again, we really care about those things and we want to respect it, we pay attention to this to only use the GitHub repositories on which we can and whose license actually allow us to train on top of it.
And this, just to quick note, Bob, you've asked a lot of questions. This is where it's really going to get to that nuance of where you get the data, how you handle it, where it gets, how you get served, all that kind of things. And these are places that have long since the reason we're doing this webinar is this is a place that we share very closely with Cohere on the necessity of looking, understanding, and transparency around these questions. So we'll continue to send that. We'll send extra links for you as deeply as you want to in these spaces. But Matthias is covering something that has been a mantra for us for a very long time. This is one of the reasons that we're super excited to work with Cohere because we'll get in also where this gets served in some other deeper questions. But these are fundamental. The questions need to be asked today. And Bob, I'm going to make an assumption you are not joining us from Europe, but for those of you that do join us from Europe or have a European presence, there's things, the AI Act that has been signed is going to be something that is critical for you to deeply wrap your head around because it says very clearly models cannot have copyrighted data. So Matthias is talking about exactly the issues that you will be facing if you want to use these technologies over the next 6 months to a year. So, sorry, Matthias, not to jump in. I just do want to put a big emphasis on what you just said, because it is definitely what we're seeing.
It's excellent. And I will continue talking about this issue challenge that we have, that we know that we have more data. How can we want to improve on this, but at the same time, how can we do this by being respectful of the authors of those data? And so what I told you until now, this idea of hiding the prefix and then revealing a word one by one, is what's called the pre-training part. There are two more steps in how you create any type of modern large language models, including the code ones. The second one is called instruction fine-tuning, where we now do ask humans to create us examples of exactly what you would expect a final user to use your model on. And then there is a final step, which is called the alignment step. The reinforcement learning from human feedback is one of the technical terms which is being used. And I will briefly mention also about this one here. But especially on the second one, instruction fine-tuning, where I wanted to say a few words about how do we make sure that the data that we are using for the second step, that we actually have the right to use this data. And so this second step is the type of data that we use is similar to the ones that we had shared before from natural language to code. We have natural language instruction, which is a long one, like this one here. It's asking for here a Python function. It's called split multivariate time series into windows. And it gives you a proper definition of what this would look like. It has a number of parameters, 6 here. And then it gives you a detailed and unambiguous description of what you would like to accomplish with this. In order to evaluate that the model is actually able to solve this problem, we have, when we get this type of data, we associate this with a list of unit tests. So I'm giving you a few here. So this uses a library in Python called unit tests. And so it has a list of tests. Here you can see 2.5, which tests different use cases. And then you see all those assertions. So there are a number of assertions. What we do is every completion that the model gets passed through all those unit tests. And if it passes all the unit tests, and then we say, okay, you're good to go. Either when we train it, we tell it, that's a good one. You don't need to change anything. Or for evaluation, there's a way that we know that we are improving or not. Now, this example that you just saw here is an example which has been synthetically generated with a previous generation of our model. So most of our data these days for instruction fine-tuning comes from a pipeline that we created internally, which creates us synthetic data. And the way it works is the following. We take a previous version of our LLM, or the best current one that we have. We ask it to generate us a long list of prompts, and we're talking about hundreds of thousands of those prompts, millions even. We take those prompts, and then we give it to the same LLM, and we ask, okay, give me some type of completions for this one here. And then it gives us, let's say, 10, 100 completions for each one of those prompts. We also ask the same LLM with this prompt, or maybe with a prompt at the completion. We try different things. We ask it also to create us unit tests. So it also creates us this code snippet here that you can see here. And what we do then is that we take the unit test that was generated, the completion, and we just run it through. And then if it passes, we make a big assumption here. If it passes, we assume that this is a correct data point, and we throw it into our training set for the next generation of our model. There could be 4 scenarios here, right? It could be that the completion is correct, that the unit tests are correct, in which case this is a data point we really care about. So this is a good one. It could be that the completion is wrong, but the unit tests are correct, in which case we would remove this data point, and that's good as well, right? So this is a wrong completion. We don't want to fine-tune on this example. We don't want to engrave this behavior. It could be that the completion is correct, but the unit test for some reason is wrong, in which case we are removing this data point, which is a pity because the completion is a good one, but that's a loss we are willing to live with. It could be that the completion is wrong, the unit test is wrong, but as the combination of them, it actually passes all the unit tests. And this could happen we have inspected the data. It doesn't happen very frequently, but this is still some type of noise that we take into account, and we decided to live with it, because the amount of data that we can generate like this is much more than what we could generate either by scraping externally and then running into some of these copyright issues we really don't want to get into, or by having our own annotators create this data. For the example of COBOL, which I showed before, we did create human annotated data, and it's because the initial LLM was so bad at generating COBOL data that we couldn't rely on this pipeline to generate more. But once the model is good enough, then we can use it by filtering in order to create data and bootstrap our own models to go forward. And so let me just say a very few words about the way that we do the last part, the alignment, the reinforcement learning from human feedback, specifically for code, because that's probably the part I love the most from a modeling perspective of working with code LLMs. Well, that's not true. The one I like the most is actually being able to use them and see how helpful they are, but that's the second one. And you might have seen some types of presentation of how reinforcement learning from human feedback works. And I will just cover very quickly the second part here, which is the online part. The way it works is the following. You have an LLM, you generate a set of completions for a set of prompts, and then you have this weird machine here, which I draw, which is called a reward model. It's basically a model which tells you, oh, this data point is a good one, this one is a bad one. And so the model reinforces a good behavior, penalizes a bad one, and then you iterate on top of it. And the way that you iterate is with algorithms which come from the reinforcement learning literature. I used to work on the reinforcement learning part of training our generic model. And the way that we worked here reminded me a lot this Guacamole game that you have in some of the amusement parks. So we ended up with a final model, and then we checked it, and then some user said, oh, your model is too verbose. It generates too much data. And then we looked at the reward model because it's a machine, and we realized, oh, the reward model actually rewards very much very, very long completion. And you might remember a few months, 8 months ago maybe, on Alpaca Eval, on the LLMs leaderboard, which is one which is very much used to evaluate these models. There was a huge bias towards models which were generating longer completions. And so what we did when we saw this is we created a training set where this shorter completion was actually the better one. And so we used this one to create a new version of our reward model, which we then used to train the next model. Then somebody came up and said, oh no, your model uses a lot this one very specific phrase, which makes it which I don't really like. Or the way that you, the style, because you always finish with a conclusion. I don't want you to finish always with a conclusion. Doesn't really work out. And then we played Guacamole. We created data for this one, and we tried to kill this crocodile. And then we moved on to the next one. What I like from code is that this reward model, which you can see here, is actually executing the code and see what comes out. And so we execute it versus unit tests, and then we can know if it's correct or incorrect. We could execute it and measure the efficiency of it. So the fact of having an objective external evaluator, which is an interpreter or the compiler, makes this process much more smooth and much more objective, and it becomes much less subjective. And I think that's a marvel of code language models. This is why we have seen such a big uptick in their capability. It's because we have, differently from, for instance, summarization, we have a way of objectively evaluating it in an automatic way by using the external compiler. And having this external signal helps us to optimize our model specifically for this use case. The same would happen for summarization. We would have much, much better summarization models. But evaluating a summary remains a very, very subjective task.
So we got a question from the audience here. How do you make sure that you don't incorporate bad, outdated code from GitHub in your scraping phase? How do you make sure that that response keeps code styles and paradigms with time?
That's an excellent question, Andreas, and one which we discuss a lot internally. There are two ways, two approaches to this one. And let me give you an example maybe from the safety. Let me try to shift the conversation to a safety one. So assume you want your model to not use any type of swear word. And the one way of doing this is to remove from your training data any type of data which contains those swear words. So your model will never learn to actually say them. The other approach is to keep those in, and then afterwards, in the alignment phase, to push it towards the use of not using them. And so with bad code, we are doing something similar. We could remove all the bad code. It's a bit hard to evaluate what actually bad style code means, but we do have classifier for these type of things. But then the model, if it would see bad code, and if it sees my code, it gets to see bad code, I have to say. So if it sees bad code, it would be totally throw all out because it wouldn't know how to deal with it. And so, for instance, we couldn't use it to fix code because it never saw the bad code before. So we rather prefer it to expose it to many different styles and to coding paradigms which are old or maybe not taught anymore because we don't consider them very good. And then afterwards, in the alignment phase, to teach it to create it in a style and in a code paradigm which is actually good. And just for information, one of the many evaluation sets we have is actually one which evaluates for code style. So we generate code and then we have a classifier which tries to figure out if this code is considered good quality or not.
Yeah, this is a great question. I want to even nuance it a bit more. There's the most current, best up-to-date Java may be useful for some companies. And again, I'm going to speak companies. So if you're a developer that's always bleeding edge, the question is a great question. If you're a company that's running and building, say, like one of the banks we have that's using Python 5 versions, 6 versions back, but that's what they want to code to, now you need to have a model that has been specialized. And there's multiple ways we go about this. Matthias has seen a couple. Got RAG. There's a bunch of ways we can specialize, which we'll hit a little bit on. But just remember, sometimes that outdated code. So there's outdated code that's bad outdated code, and then there's outdated code in terms of depending on who you're talking to. So this is part of the process of the difference between a general model that is really good for an individual developer, student, and this is the full view of all of GitHub. I'd say this is a little bit more how some of our competitors tackle it versus the way that Cohere and Tabnine think about this challenge, which is often is going to take into the nuance and the specialization necessary for the use cases of enterprises. So again, you come at these with different views and requirements and kind of leads into sort of this conversation. So the questions have been good. I think we're going to cover most of them. I want to hit a little bit of how we fit these now together. So this is shared values across Tabnine and Cohere. The importance of respect for integrity, confidentiality of your code base and how it's used. That privacy, we both hold to. That's how we use it. Personalized, this is what we just talked about. The ability to tailor that to the code, your team, awareness, company standards, that kind of stuff. I'll hit a little bit of, you'll see this in a sec, and Matthias will jump in and say, yes, similar, and we do, both of us work on this problem together. Our teams talk pretty regularly on R&D around these questions. And then finally protected. This was a lot of questions that were asked earlier. And to be crystal clear from that standpoint, we don't store, keep, or train on any end user's data. That's the policy. That will always be the policy. Now, if you're an enterprise and you want that to be trained on and have a custom model, awesome. But then just to be crystal clear, that is your model living in your world, not used anything, never sees the light of day other than for your use case. So just a little bit of context sort of to kind of pull these together.
And I can confirm this as well. I see many questions around, what happens with my stuff which I sent from Cohere? If you use us through Tabnine, we don't get to see your data. I would be the first one who would see it, and I can assure you we don't get to see your data.
Yep. So, and I think we should also just highlight, it isn't because you guys don't have great data, and this is an ethical decision, but it has trade-offs, and it's you all love the ethical piece, but I am going to be clear to everyone here. You have to understand, the best way to solve this problem oftentimes is to take any data that comes in the front door. That's an ethical decision that both our companies have made not to use. So if that matters to you, if it doesn't matter to you, then there's other options that have been trained on that kind of data. But if it does matter to you, this is one I think you should really consider, and it's going to become more and more important. We talked a little bit about fun use cases here. I'm going to keep moving, but again, highlighting on the bottom, this is data that we aren't using your data to train the models, unless, again, you want us to train it for your model. But again, your model, no one else's. A little bit of data. So this was interesting. So we like to compare notes and go back and forth on this because, and there are two views of it, and the two different views is like having two eyeballs. You can actually focus on something much better if you have two views and you can center on them. Tabnine, we don't store any user data. So let me say that crystal clear. But one thing we do take from our 1 million+ developers is if you accept a suggestion, we keep it as like, they like the suggestion. If you accept it, that's a very good indication that which is given to you was good. We don't keep it all what it is. We don't have any extra data of what it was. But that at aggregate, when you talk about millions of developers using it, gives some very good data. So for example, around the use case of fixing code, right? This is a really, really good indication that when you're asked to fix code, and this is just using one of use cases, we can go into to many others, but the Command R model is very strong at this. This is a really good example of real world use cases. And for context for everyone on that's on the call, if you Tabnine Enterprise, you can get this reporting for your team as well. So your team would say, hey, how much of what we're using is being accepted? This is very, very fundamental in ensuring that you have a good model that's working well. If we specialize the model, that it continues to be a solid model for you. And it gives you good indication if you're either having model drift or your developers are working in maybe a different area, in which case perhaps a different model is needed, or we need to go back and look at what we've done, rebuild a RAG or some other options. So these are just good indications, but I want to highlight there's different ways to think about this problem. There's the core ones from a very much a data science view and from a model view as Matthias has looked at it, and we have the acceptance, which is again, at a small level, not useful, but when you're talking about a lot of users, this is a pretty interesting indication of usability. So I think on this one, I was going to give Adrian, I think right here. Adrian, I know everyone likes to see something. So you had a fun little demo example. I was going to just let you switch over briefly.
Yeah, sure.
Let you kind of show this in work, and then we'll kind of switch back and finish up. But it's not real if you don't get to see it, and Adrian's the one that brings everything to life. So
absolutely. So for this demo, I'm going to be using Visual Studio Code. That's typically what I use. For those of you who don't know me, I like to consider myself a full stack developer, whatever that means in this day and age. But I had been working with Matthias, and we've come up with a couple good examples. So one is showing off how to use Command R+ with our Explore Codebase feature. So this is if you are new to a project, if you're wanting to get ramped up. This is our agent that will scan scan your workspace and give you a nice summary and even prompt you for other questions that you could ask of the code base. So here you can see that I've selected Command R. If you are using Pro or Enterprise and you have it available, you can select that, and you can see here's our Tabnine protected model. But down here we have Command R+. And so we can select that. Oh, right now I just have the project open. You can see up here it says LangChain. So all I have done is clone that repo, and I've opened it up for the first time, haven't looked at anything, and I'm just going to go to Explore Codebase. And so it's going to do some looking at different files in there and the README, things like that, and it's going to spit out this nice summary. So we'll give it a second. It's generating relevant follow-up questions. So if this was your first time and you wanted to contribute back to LangChain, this would give you a nice little summary. So we got the project purpose, the key components, which are nice, a little section on how you can get started, project structure highlights, which are great, and then a nice little summary at the end. But then we also give you some questions so you can dig deeper into the project. So like, what is the primary purpose of the project? How are the key dependencies required for setting up, or what are? How do I install and use different templates provided in the project, etc.? Or you can just ask your own question. The other thing that we went over was over here. So because it has such a great understanding of different coding languages, we can do things like documenting code. So we can actually select this whole class here in Python and come over here and say, document this class using Cohere. Oh, this class and include inline comments explaining the purpose of each method and property. Yeah, that sounds good. I love that. That's a new feature that we've added where we actually give you recommendations for the prompt. So if you're one of those people that's like, I have an idea of what I want, but I could use help coming up with the prompt, that's new in tab 9 now. So that's pretty nice. Sometimes I just like type a few things and wait, and I'm like, yeah, that's what I wanted. So as you can see here, it's spitting out the whole class. It is documenting it using the Python style of documentation. And we're even getting the args and even whenever it returns something. So this is nice. And if I wanted, after that spits it out, I can just tell it to insert that in and go on to the next class or anything that I'd like to document. And the last example that we talked about was the fact that Cohere is actually really good at multi-language. So you can ask it to return results in a different language. You can ask for the prompt in a different language. While I have studied like Latin, German, and now Japanese, I don't have the proficiency level to code using those languages. So it's a little harder for me to try it out. But I think Matthias knows what French, German, etc.
Maybe somebody of the audience has like a generic question about a popular code base, which we could try. I'm being very risky here. So if somebody would like to have a question in a different language, they could throw it in and we can try it out.
Copying and pasting different languages is really easy for me.
Right.
But we can go back here. Do you have a question? Yeah, audience suggestion for a question about LangChain, maybe in a different language.
How about French? Just going to go out on a limb here. Let's ask a French question to this one around language. Something about the LangChain project that you'd like to know in French.
And while we're waiting, Matthias, why don't you go?
I'm putting on Matthias because I.
Yeah, why don't you put something in the private chat that I can copy and paste over while we're waiting for somebody to respond. I'm going to start a new conversation here.
We'll have to have also a translation. So
yeah. All right.
Because I won't understand the French. I'm sorry.
Here we go.
Okay, the one I put here is just it's the typical RAG question that you might have, and though LangChain allows you to combine those and to create your external RAG things for documents. This is just one which assumes that you have PDF documents in a folder called documents, and so you want to set something up where you can ask it questions on top of it. Okay. And I have no idea if this is going to work. Okay, so it tells you to use a library which is called PyPDF2, and then you can see that even the comments are in French, and it's you can read the code, I guess.
Oh my gosh. Yeah, here's code.
Code and comment, all in French.
Yeah.
Okay, Adrian, now try out what Andreas said. He has a follow-up question in German about an alternative implementation.
That's good because I would know that that's what's asking. Is it alternative to?
And now Now you might throw off the model because it might not know if it wants to answer you in French or in German. You can see what.
Oh no, I can't copy it from there. Hold on, I can copy it from over here. Let's see, can you for me another implementation? Is that for Schlagen? For show me another.
Propose. Yeah.
Yeah, propose.
Oh, you got it. I copied over. Let's see how it goes.
Sicher.
Okay, and so this one uses a different library. It's called PDF-6.
Oh yeah. Die Bibliothek.
Yeah.
Fun. Yeah, I think the language stuff is really fun. So
good. Well, we're going to keep moving, although we'll see how many languages. This sounds like a future workshop level of fun. But the point from purpose standpoint, so with just a couple things here, we're just going to sort of like tie the bow back together, at least for today. That said, both teams are thrilled to jump on and go in more detail with anyone that's interested. When we look at this, the partnership here again comes from the very top all the way through. So from the founders of both companies talk all the time. Our R&D teams trade insights, ideas behind that, and that's because, to be crystal clear, as you understand, Tabnine is not a model company. We have offered a model. We started by offering a model. We still do have a model. That just simply had to do with where we were and with the fact that no one else had ever built these in the past. But our goal as Tabnine and Cohere is to give you the best solution that is fully secure and that meets the requirements that we see coming down the pike, whether that's in Europe or the US or otherwise, and to do that both ethically and above board. And so, yes, Tabnine does offer, we will always offer multiple options. That's part of the requirement, sort of where we live. The work with Cohere is going to continue in depth, day in, day out, to build this better. And particularly the code use case has been one that we've all talked about pretty regularly as a team. If you want to get started, you'll get that. You guys will get a note whether if you haven't yet individually, jump in, get to using this a whole bunch. If you're an organization, so I'm going to speak again to kind of two groups. There's a group that's developers, jump in, Tabnine Pro ready to go for you. For those of you that maybe work for an organization, what we want to highlight is some very detailed work we've done with Cohere to make this available on an individual, so you can get your own specialized or your own instance of Cohere running inside of on OCI, Oracle, and that's completely set up in your own VPC. You're off and running. You can do specialization, RAG, all the other things that we've kid on a bit today. But if you're around an organization, we'd really enjoy having a deeper conversation with you. We've set this up with the design focused on helping developers inside of large complex organizations with serious constraints meet those requirements. And so we've developed that together with Cohere. We'll continue to develop that with Cohere as a great opportunity for you all to dig in. And we're going to continue with Cohere. We saw some of this today, but the models are amazing. But to be clear, the data that goes into these models comes from many places. So that's another area that Tabnine is working heavily. You've seen us with integrations into Jira, into the rest of your Atlassian suite that will extend to other things early in the plan schedule. It'll move down into, and we support in the testing, fixing, documentation, things from Confluence, also data from many other sources. All of these get pulled together to give you much better context inside of whether that's your personal RAG or to the way Tyus highlighted. We fit that and specialize that model through synthetic data or a bunch of other options. These are all ones that are on the table. We'd love to work with you on to ensure that you get the very best for your developers, your team, no matter where you're coming from, no matter what code base you have, and no matter what your security requirements are. So again, this is what we're working on. We start with the basics of really, really strong models that we've looked at that are secure, have been only tested on and use fully permissive code, as Matthias has said. Then we start adding the context, connection, coaching, and customization. These are all areas that both Tabnine and Cohere work together to deliver for you. And then you're off and running. And what we've seen time and again is, while large models are super valuable and they are a great foundation, as Cohere has proven, Cohere will tell you as well, like the future of a lot of these models, it's always going to be better if you can specialize. And that's going to come from good data from your world and what you need to solve. And we're here to help you do that and do that well. So I know we've sort of reached the full hour. Hopefully we've hit most of the questions. I would like to thank Amaya also for being diligent in putting a huge number of links and context up there, which is super valuable. And for us, please, you'll get a bunch of data coming out from us. You'll get some follow-up emails, but do not hesitate. Neither company hides. We are not difficult to find, and we would look forward to helping you solve and deliver this, particularly into your large enterprises. The challenges that enterprises have look, as you may have figured out, quite different than the individual developer. That said, we've set it up for both companies to set you up. You can do a quick API key to any one of all of Cohere's great models. Those are available instantaneously. Tabnine does the same. So wherever you may be coming from, we'd love to continue to engage with you, and we do really appreciate you spending some time with us today. And I think that would be holistically. Any last comments from Matthias, how many different ways I can give you a name? You're welcome.
I should have introduced myself as Matt. It makes it much easier.
Just stick to Matt. Just stick to Matt.
Just going to call him M now.
Oh, yes.
Right.
But any last comments from you all?
Yeah. If anybody has a question, as Brandon said, I'm pretty easy to find on most old social media, I guess. So don't hesitate. If you or your teams want to ping me with a question, I would be more than happy to continue the conversation offline.
Yeah. So where can they find you most places on the internet?
You can find me on what's called now X, so Twitter. You can find me on LinkedIn. And I guess you can even find my email by looking for some of the papers, for instance, that we published.
Awesome. And then, yeah, I'm found most places on the internet at It's Adrian, ITSAYDRIAN. We want to thank you for coming to another Tabnine Live. We will have another one in 2 weeks, so stay tuned for that one to be posted, so you can, RSVP and all of that. And then also want to plug every Tuesday. Every Tuesday at 3 p.m. Eastern time, I will be running Tabnine Live on all of the platforms. Not Tabnine Live, that's what we're doing now, Tabnine Labs. So if you are a fan of live coding and you want to see me use all of the newest features and try different things with Tabnine, that will eventually become content that you'll find on our blog, then feel free to join me. Ask me questions, and maybe even help me out. So last Tuesday I did a Chrome extension that I've never done before, all with the help of Tab9, and I think it was pretty successful. So I'd love to see you come out.
Thank you all. So appreciate you joining, and both of you, thank you so much for the help. It was great.
So lots of fun. Thanks everybody.
Let's get some outro rock music. This is my favorite new feature. But yeah, thank you all once again, and TTFN. Bye, all.